You're welcome to my channel. This afternoon I'll be talking about oxidation and reduction. So I want you guys to pay max attention to the class. As you do, don't forget to subscribe, watch to the end, and also share within your colleagues and friends. So guys, let's move back to the class. What is oxidation and reduction all about? Simply, when talking about oxidation, oxidation is addition of oxygen, while reduction is removal of oxygen. So it starts now, and one thing you should note is that the combination of these two will give us what we call a redox reaction. So now, this two now I'll be explaining the oxidation and reduction with respect to four headings. The first one is addition of oxygen. So now, what is the meaning of oxidation and reduction under the addition of what? Oxygen. Oxidation is defined as the reaction in which oxygen binds with a substance, while reduction is the removal of oxygen from a substance, or we call it a compound. So now, looking at this two now, how does oxidation and reduction affect or any compound? For example, now we have this copper 2 oxide plus hydrogen gas. We have this. I have copper plus water. So this is what solid. We have gas here. We have solid here. We also have what we have here to be what? Liquid. So now, and don't forget that I said oxidation is the addition of or oxygen combined with a substance or compound, while reduction is the removal of oxygen from a substance. Now, so looking at these two arrows now, this go for this, and this what? Go for this. So now, with the knowledge of that particular definition, looking at what you have on the board, it will come to your mind that, okay, is it the arrow at the top that represents oxidation or what? Reduction. So I will mind you now, this copper 2 oxide here is being reduced. Copper 3 is being reduced to what? Copper 2. While this hydrogen gas here is being oxidized to water. And don't forget that the addition of oxygen is oxidation. So at the reactant side here, the hydrogen gas here does not have any oxygen. So moving to the product side, it has what? Attracts or combine itself to give us what we mean by what? Water. So the second one is what? Copper 3. So now, oxygen is being removed from this substance, meaning that this is what? Reduction. So the next another example of this addition of what? Oxygen. I have ions plus this. So I have these to be plus. So looking at what you have on the board now, I want to show you guys that with this now, or with your knowledge of this now, you can identify which one is oxidation and which one is what? Reduction. So I have this. I also have what? This. So this place now. So now, when looking at it now, the removal of oxygen, we are meant to know that it is what? Reduction. Why the addition of oxygen is oxidation now. So look at this iron 2 here. It's being oxidized to iron 3. So it means that iron what? Added oxygen or combined with oxygen to give us this compound, and here we have water here. So as soon as I remove this oxygen here, I have what here? Hydrogen gas here. So it's that I call this reduction. Why? Because we remove what? Oxygen from the substance. Why this one is what? Oxidation. Addition of oxygen. So that's the first explanation on the addition of oxygen. The second one is removal of hydrogen. Removal of hydrogen. The first one is addition of oxygen. The second one is removal of hydrogen. So note one thing: the definition of oxidation is further extended to mean removal of hydrogen. So now here we can say what? Oxidation is removal of hydrogen, while reduction is the addition of hydrogen. So looking at this now, there are two different things entirely. When we are talking about the addition of oxygen, we added oxygen, or oxygen combined to a compound or substance to give us oxidation. While we remove oxygen from a substance to give us what? Reduction. Here we are talking about the removal of hydrogen, whereby oxidation is removal of hydrogen, while reduction is addition of hydrogen. So let's look at this particular example. I have this hydrogen sulfide plus chlorine gas. So we have this plus sulfur. Mind you now, if you are given a question like this, be careful. So this is being oxidized to give us what? A yellow sulfur. While this one is being reduced to give us what? This. So now with this now, our main purpose of this particular example is for us to identify which one is reduction and which one is oxidation. So with this now, looking at this compound here now, hydrogen is here with sulfur. So for it to have removed the hydrogen, it makes us what? It means that this oxidized to give us what? A yellow sulfur. So with this now, I can call this removal of hydrogen is what? Oxidation. Why addition of hydrogen to a substance is what? Reduction. That is for the what? The second one. So the third definition of oxidation is addition of electronegative elements. So what is the definition of oxidation under the addition of electronegative? I'll make it short. So take note that oxidation is extended to mean the addition of electronegative elements and removal of electropositive elements. So I can say oxidation is the addition of electronegative elements and removal of addition of electronegative elements and removal of electropositive elements. Why reduction is the addition of electronegative elements and addition of electropositive elements and removal of electronegative elements. This part of this oxidation and reduction is very complex. Mind you, our main focus should be electronegative and electropositive. So class, what is electronegative? They tend to attract electrons to themselves. So example of these particular elements are those elements, they are all nonmetals. So I have this, can have fluorine, I have carbon, I have oxygen. All these elements, they attract electrons to themselves. Why electropositive? They lose electrons. So now, those elements that lose electrons are called the metals. I have sodium, I have magnesium, I have aluminium, like that. So now, let's pick a good example of this. But before we do that, I would love to show you guys the order of decreasing in electronegativity and increasing in electronegativity. So now, I have this arrow. So I call this electronegative decrease. Whereby we have fluorine, we have oxygen, we have chlorine, we have carbon, I have this, I have many of these particular, I have nitrogen. So there are many compounds that shows the electronegative decrease. So now, the other one, all these are non-metals. All these are non-metal. So the next one is electronegative increase. The metals, sodium, magnesium, aluminium, calcium. Okay, I have bromine also. So now, with this now, I'm going to pick this. I'm also going to pick what? This chlorine. So explain the addition of electronegative elements and removal of what? Electropositive elements. So I have calcium. The calcium here is solid plus chlorine gas. We have this arrow, calcium chloride. So looking at this now, before we identify which one is oxidation and which one is what? Reduction. Here, calcium is oxidized with the addition of chlorine. While chlorine is reduced with the addition of what? Calcium. So take note that calcium and chlorine are good oxidizing and reducing agents. So with that, I have this. Mind you, calcium is electropositivity. The electropositive element, while chlorine is what? Electronegative element. So this is called the oxidation. And here, we have this to be reduction. So now I would love to take another example on this. So I have this plus this. So what would it give us? Are you with me now? I have this, I also have what? This. So I can decide to have this. So this is what? Bromine gas. So I have this here plus the sulfur. So now, we want to show which one is positive and what? Electronegative. Mind you, sulfur is a good example of those elements in electronegative decrease. And bromine also is what? Example of electronegative decrease. So hydrogen is not what? So we all know that hydrogen can be found to be an element that combine with either the halogens, the nonmetals. So now, with this now, I can show you that this particular one here is the oxidation. Why this one is what? the reduction. So it's that you have, I can put RA, I can put what? O here. So don't forget the electronegative decrease and what? Electronegative increase. It tells us how we can determine the oxidation and reduction with respect to addition of electronegative elements. So the last one is okay. So as I'm saying earlier before that, the first one is transfer of electron. So I deduce that for every transfer of electron, we must have oil and Rig. So what's the meaning of this oil? Oil means oxidation is loss of electrons. Why this is what? Reduction is gain of electrons. So now a good example is when iron 2 chloride, which is this, reacts with chlorine gas, we have iron 2, we have what here? This. So now when you count the number of chlorine you have here is 6. I also have what here 1 now. So what we want to identify here is the oxidation and what? The reduction. So here we have it to be oxidation, while here we have it to be what? Reduction. So now we have Fe2 plus to Fe3 plus. So from this to this, you can see now from 2 to what? 3. Reduction is what? Gain. So you can, it tells us that what? This transfer of electron is correct using this particular equation to explain it now. So guys, don't forget to watch, subscribe, like and share within your friends. Thanks for watching.